Okay, see Lindelof videos, indefinite integration number 22. Remember, for integration, we're saying that we're going to find the function whose derivative is this thing on the inside. So in the same way that we rewrite things to differentiate them, we're going to rewrite them when we integrate sometimes so we can see it more clearly. So what I'm going to do here is I'm going to integrate this by parts, just like the sum and difference rule. So I'm going to say that this, I want the indefinite integral of x to the 1/2. This 1/2 is a perfect representation of this square root. So we're allowed to do that, right? So I'm going to do the same thing here. Here we have a constant multiple, and we can factor out a constant multiple. We have a constant multiple of 1/2 here. So I'll pull this 1/2 out. The indefinite integral of, we have the square root of x here, but it's in the denominator, so it's not x to the 1/2, but x to the negative 1/2. Right? Remember, I write dx here, and I should have written dx here because I have two of these pieces, right? So I'm going to go ahead and I'm going to integrate them piece by piece. So as I do that, as I bring this piece down, as I start to integrate, so when you integrate, you get rid of the integral sign. So I'm going to integrate now. So I'm going to take this 1/2 plus 2/2, right? 1/2 plus 1. We're going to increment the exponent instead of decrement it. And then we would do the same thing here. We'd have 1/2 plus 2/2 at the bottom plus c. This is me integrating this piece right here. I'm going to go ahead and integrate this piece right here, which is this 1/2, and it's x to the negative 1/2, isn't it? Plus 2/2 all over negative 1/2 plus 2/2. I'm just showing you this bit like this, yeah? And then I'm going to put plus c on the outside, so my plus c goes there. I normally wouldn't show you this much detail. I would just do this, but I just want to show you in this particular video how I'm doing this. So I get 1/2 plus 2/2 is x to the 3/2. 1/2 plus 2/2 at the bottom is 3/2 at the bottom, plus c, I should have put c sub 1 here, plus 1/2. Here I get negative 1/2 plus 2/2 is x to the 1/2, isn't it? Over 1/2 plus c sub 2. Your professors will actually be kind of picky about this. I can kind of hear people say, why are you writing c twice? Because I integrated these as separate pieces, so I had to come up with that constant of integration for both of them. Remember, this is a complex fraction. So this 3/2 comes up as 2/3. 2/3 x to the 3/2 plus c sub 1. This comes up, right, as its reciprocal. So 2 times 1/2 is just 1. So we get x to the 1/2 here, don't we? Plus c sub 2. Your professors are especially jerks about these pieces here. I want you to know that c sub 1 plus c sub 2 is just equal to another value of c. So it shouldn't matter. You should ask your professor how they feel, or your instructor how they feel about this. So I guess I would actually combine these and get c sub 1 plus c sub 2 is equal to c. And I would write that the value is x to the 3/2 plus x to the 1/2 plus c is the indefinite integral of that. How would I know that that worked? How would I know that that worked? I would know that that worked. I would know that that worked by taking the derivative of this. So if I differentiate this, I should get that piece, I should get that back. So let me say this. This is my answer. Proof of my answer might be this. 3/2 times 2/3 is 1. Say we decrement here, so we take 3/2 minus 2/2 is 1/2, right? Plus, the first derivative of this is 1/2 x to the negative 1/2, isn't it? And if we look at this, x to the negative 1/2 is square root x, isn't it? And the first derivative of any constant is 0. So is this where we started? So remember, x to the 1/2 is this, isn't it? Square root of this. So is this what we started with up here? And hopefully it is. And there it is right here. All right? So that would be my proof through differentiation. If you have any questions or comments, please let me know. If you haven't already subscribed, please do. Thanks, you guys. Peace.